Section 1.2, measuring and constructing segments. So what we're going to do is we're going to look at one of these specific terms from Section 1. We're looking at line segments, measuring, constructing them, and what are some of the things that we can do with line segments. Because a segment is finite, it's quantifiable. You can measure it, you can assign a number to it. Once you have a number assigned to it, you can do some pretty cool mathematics. So the distance between any 2 points is the absolute value of the difference of the coordinates. All right, so technically distance is an absolute value. It's always positive, okay? If someone asks me, Mr. Fay, how far do you live from school? And I was like, I drive negative 20 miles to get to school. They're gonna be like, what's wrong with you, okay? Like just say 20 like a normal person. So distance is always positive. So that's why they have that absolute value in there. Now, one of these postulates, Euclid's rules, all right, an axiom, you accept it as true without any proof, is the ruler postulate. The points on a line can be put into a one-to-one correspondence with the real numbers. Here's what that means. What that means is that 3 inches is always 3 inches. It's always the same distance. It doesn't change, okay? 3 inches isn't a certain amount on Mondays and Wednesdays and Fridays, and then it's a little bit shorter on Tuesdays and Thursdays because it needs to take some kind of break. It's always the same. It's a one-to-one correspondence. What Euclid is saying is that you can measure things. We can set up systems of measurement. Now, who decided an inch was an inch? And that 12 of them makes a foot, and 3 of those makes a yard, and 5,280 of these feet are a mile. I don't know, but it's that whole idea of postulate and axiom. You accept it as true without any proof, okay? In this country, I am 6 feet 2 inches tall. Other countries, I am not. They have a different way of measuring it, but in this country, we use feet, inches, and we accept it. So to find the distance between these points, between x and y, now we have this number line here. There's a couple of ways you can do this. You can use the absolute value definition, absolute value of the difference from x to y, or you have a visual. You can absolutely count 1 unit, 2 unit, 3 units, so on. X to z. All right, going from a negative to a positive amount. You can do that definition, the absolute value of the difference, or you can count it out. Either way is fine, but take a moment to look at A and B, do that math, pause the video, check my completed notes, and once you have that, you move on. So when you are measuring segments, eventually you're going to come across some segments that have the same measure. And we got kind of a specific word in geometry for those. Those are called congruent segments. They're segments that have the same length. Okay, in the diagram, which I'm going to draw, we have segment PQ. We have segment RS. And we're going to say those have the same length. Their measures are equal. So that means we can also say they are congruent. That's that equal sign with a little tilde over it. Now, visually, how we say things are congruent, just put a little tick mark right there in them. That tells us that they are congruent. And congruent, what it really means is exactly identical in all ways. So it's the same type of object, and then all the properties of that object are also identical. In this case with line segments, they really just have one property. It's their measurement. A line segment is a one-dimensional object. It has that one dimension that you can measure it by, the distance. Now let's say we have a second set of segments that are also congruent, but they are different from the first two. Well, what we do? 2 tick marks right in there. Say they are congruent. They are identical in all ways. Now this is where Euclid really starts building on himself. He says, okay, if you can have an object, a line segment, a finite amount from here to here, you can measure it because we have the ruler postulate. Well, now we have a quantifiable amount. If you have a quantity, you can do arithmetic. Add, subtract, multiply, divide. So we get the segment addition postulate. If point B is between A and C, so they all rest on the same line segment, all right? That means that AC, wherever B cuts it up, AB, part of AC, BC, the other part of AC, those two pieces added together will give you the whole amount. All right? So when you take like a chocolate bar and you break it in half and you're like, oh man, do I still have the same amount? You can just like put them back together along the seam and be like, oh yeah, it's still a whole chocolate bar. Okay? Now this is important though. You have to know this. That M is between N and O. So we know that they are all on a single line segment. So this tells us we can use the segment addition postulate. And then we want to find NO. So we know by the segment addition postulate that NM plus MO equals no. So now we can do some fun substitution because we have quantifiable amounts over here. We have algebraic expressions. 17 is the NM. 3x minus 5 is MO. And no is 5x plus 2. So now we have an algebraic problem that you are very competent in. All right? Take a moment to pause the video, solve the rest of this problem, and this is something I'm going to refrain a lot during the school year. Make sure you are answering the question that's being asked. All right, what does this problem say? Does it say solve for x? Or does it say something else? Make sure you're answering the question that's being asked. When I walk up to you in the hallway, I'm like, hi student, how you doing today? And you're like, I like pizza. It's like, okay, it's good to know, but you didn't really answer my question, okay? Maybe I can infer that you're in a good mood, but you haven't really answered what I've asked you. So take a moment, pause the video, figure this problem out, check the completed notes, and then we'll move on after you resume the video. So the last piece here is if you can take point M and you can slide it around NO, eventually what you can do is you could put it smack dab in the middle. And then it would be a midpoint. All right, the midpoint is on a line segment, and it, kind of a new word here, it bisects. It bisects, or divides, the segment into two congruent pieces. Now, congruent means identical. Line segments have this property of distance. So if they have an identical distance, that means that the two halves, their measures, are equal to each other.